Alright, we're getting close to the end here. Looking at this question, question number 1 that is, I see I'm going to have to deal with multiple rules. So the first rule I can spot is within my brackets, and that's combining like terms. I'm going to have to use my quotient rule. So that's going to be number 1. Question number 2, once I do that, I'm going to have to distribute this too, but I've got 2 pieces inside my bracket still. I've still got P and Q. So I'm going to need to use my power of product rule. And finally, I'm going to need to apply my power of a power rule once I've distributed this square into both my variables. Oops, and I'm not sure what happened there. Oh my goodness. Okay, power of a power. So that's the order I'm going to tackle this in. If you chose to do it in a different order, that would be totally fine, but I like to condense things as quickly as possible. So that's why I choose to do my quotient rule first. My first piece is collecting my like terms. And so, I won't change my color just yet. That leaves me with, in brackets, P -7 minus 2 and Q 2 minus -8. Now that square is still on the outside, so I leave it there. And that simplifies to P -9 and Q of 10 squared. Distributing it, I've got P to the -9 squared and Q to the power of 10 squared. Okay, and that's my power of product rule. And then I need my power of power rule. So P2 times -9 is -18. Q10 times 2 is 20. Now again, I am not done. Negative exponent. And so my final answer is actually going to be Q to the 20 divided by, and I flip that negative exponent into the bottom to get rid of it. I take the reciprocal, and that is my final solution. So there are technically 4 rules we need to use in just this one question. Looking at question 2, it's slightly different because of how it's formatted. I'm actually going to tackle it in a different order. So again, I'll use black to kind of lay out my plan. Number 1, I see I've got an exponent outside of this product. So I've got a power of products, and I'm going to deal with that first so that I'll be able to then piece together these 2 separate halves that are multiplying. From there, I'm going to collect like terms. And so that's going to end up being my general product rule. And then 3, I can already see there's some negative exponents floating around, so they're probably going to stick around, and I'm going to deal with them at the end. So what does this look like? Switching back to red. Step 1, power of product. Writing in the wrong spot there. That means that this -3 is distributed to both. Oh, you know what? And that means I'm also going to have a power of power rule showing up. Totally overlooked that. Sorry about that. So first things first, I've got a to the -2 to the power of -3 and b to the -3. That's my power of product rule. I still also have this a and b to the -7 tacked on the end. Power of power rule is showing up right here on this first a. Multiply the exponent, so a to 6. Negative times a negative is a positive. 2 times 3 is 6. I've got b to the -3, a to the power of 1, b to the -7. Now I can use the product rule. I've got my a's. And that ends up being a to the 6 plus 1, and adding for my product rule. And it'll be b negative 3 plus negative 7. So that tells me my overall answer is going to be a to the power of 7 and b to the power of negative 10. But again, that negative exponent is spoiling my plan, and I end up with taking the reciprocal in order to get rid of it. So b to the power of 10 in the denominator is how I deal with that, and that is my final answer. So far we've just had variables. Question number 3 actually has some constants as well, but otherwise it's set up very similar to number 1. So how I tackle this one is similar approach, but I'm also going to simplify those values. So step 1 was collecting like terms. So in this case I've got constants, my u's, and my v's are all separate. So step 1, and I'll write it off to the side so I have a little bit more room since I ran out of room on number 1 there. Negative 6 divided by negative 2 is positive 3. So I can simplify that part right off the hop. And I'm actually going to just have this as one single line. Collecting like terms, this is a quotient again. I'm dividing, so it'll be u to the negative 5 minus your denominator exponent. So in this case, minus 4. And v, it'll be 2 minus 3, because 3 is the exponent in the denominator. All of this is so squared. I'm going to simplify it. 3u to the power of negative 9v to the negative 1 squared. Now at this point, you can deal with those negatives if you want, or you can hold off until the very end and take the reciprocal of them then. That's what I'm going to do in this particular case because it lets me deal with my power of products rule, then my power of power rules, and just handle all the negatives at the very end of this. So, power of products means it's 3 squared because the 3 is also multiplying. Do not forget the 3 and just leave it on the outside. It is part of this scenario. It is the third wheel, so to speak. We also have u. U to the power of negative 9 squared and v to the negative 1 squared. So 3 squared we can simplify. That is 9. U, we multiply now. Power of power rules. So it's u to the negative 18 and v to the negative 2. Again, we don't want those negative exponents, so my final answer in this case, 9 stays in the numerator since its exponent is positive. But the other two get bumped down into their reciprocal form, lose the negative, keep the exponent value, and that is my final answer.